Hello and welcome. Today I'm going to be doing a frequency response test on this Pioneer SX-690 stereo receiver. Not too long ago, I think it was a few days ago, I actually did a phono preamp test using this receiver, and it was of course the equalization test. So now what I'm going to do is use my chart from then. Now this receiver I looked up is rated from 5 to 100,000 hertz, plus or minus 3 dB, 3 decibels. My chart doesn't go that far, and since basically the range of human hearing is from 20 to 20,000 hertz for those that have good hearing. For those that are older, it's going to be somewhat less. What I'm going to do is measure from 20 to 20,000 hertz, and then just for fun take one measurement at 100,000 hertz. Now when I do this test, let me go ahead and move the receiver over so I can tilt it over so you can see what I'm talking about. And here you can see I'm kind of already getting set up here. I have my dummy load in the 8 ohm position. I have to use the dummy load this time because I'm not strictly testing the preamp. It's all going through the power amp. And I've got my AC voltmeter leads hooked up to the hooked up here across the loudspeaker terminals, and also I have an oscilloscope just to monitor things. And the signal itself is going to be fed here. Now this is the test leads coming from the audio generator I'm going to be using. It's a combination 3-in-1 unit, so I got a little bit more room here. And I'm going to be feeding this into the aux input, not into the phono preamp input. So my input's going to have to be higher. And of course I can remove this here. I still got the old cable here when I did the preamp test. Now I'm going to do this test at a 1 watt output, which is 2.83 volts RMS. What you could also do is turn it all the way up maximum until it starts clipping, and then go ahead and turn it down by about 3 dBs, which is, as far as I remember, that is about 70% of your maximum reading, and then do that test from there. But just for demonstration purposes, I'm just going to stick to the 1 watt thing. Also, all your tone controls and everything, that's got to be set to a neutral position. Same thing like your loudness control over here, that's got to be off. And your balance control, you got to make sure that's evenly balanced out. And in case you have any kind of filters, now some of these larger units, they have you'll have like different filters, those got to be all in the off position. Basically everything, what I'm trying to say, everything's got to be completely neutral. Using this old Tech 2235 scope to monitor things. Using this National audio analyzer here, I'm going to be using the here the voltage scale, and it's got a built-in oscillator. I'm going to be using that. So the first thing I'm going to do is check if I'm getting a clean output from this, which most likely I am. It's two. When you're using a analog voltmeter, you're going to have to be sure that the frequency response is adequate. You know, that it covers from at least from 20 to 20,000 hertz or so. But you see, when I put these instruments here on my test bench, since it's so small, things get pretty cramped. So I want my input to be 150 millivolts right here. I'm on the 3 volt scale, and that's 150 millivolts right there. And I'm feeding that into the aux. And again, the frequency is going to be 1,000 hertz for starters. That's going to be my reference. Now here's how that 150 millivolt RMS signal at 1000 hertz looks, this sine wave, and it's looking okay. So now I reconnected the oscilloscope leads and the leads from the AC voltmeter. They're across the speaker terminals now. And I've turned up the receiver volume control to give me about 2.8 volts, which is about 1 watt. And here's that signal on the scope. In fact, the way I've got it set up right now, I could run through all the frequencies and see if something was down just by watching the waveform, because it show, you can see the peaks are almost at the edge of the screen, and it should stay like that, or pretty close. I think this receiver, is rated for 5 to 100,000 hertz plus or minus 3 dB. Well, that is somewhat of an expanse there, and it also plus or minus 3 dB. That is a little ways up or down. And it's also worth mentioning, this is my 1000 hertz sine wave. That's my reference. And here's 1000. Here's 1000 right here, and that's where I'm going to make my first mark up here. You see 0 dB meets 1000. That's going to be my reference. Now I made my first little mark here, and what I'm going to do, I'm not going to go through all of these steps that I did with my phono preamp test. I'm just going to go 20, 50, 100, 200, 500, 1000, 2000, 5000, 10,000, and then 20,000. So let me go ahead and get the next reading. So here's my reading at the next frequency, which is 2000 hertz. You can see actually really hasn't moved. 2000 hertz. And here's the oscilloscope. Of course, I had to change. It was getting scrunched up, so I had to change the horizontal here, and still the same. So same thing at 5000 hertz. There it is again. It's about 2.8 something. So again, that output level I started out with was about 2.8. I wanted to have it at 2.83, which would have been 1 watt output, but it's not that important. And 5000 kilohertz, 5000 hertz. And here you can see the output from the scope. And here's 10,000 hertz. The output from the scope. Nothing's really changed. 20,000 hertz. Nothing's really changed. I mean, sometimes it's just minimum. And 20,000 hertz. And here 20,000 hertz. Waveform still has the same height. Now here's at 100,000 hertz, and remember we started out with 2.8, now we're down to 2.0, and that was our reference here, 2.8, so that would have been right on this dB marking here. So we would take 1, 2, 3. So it went almost to three markings down, so that's minus 3 dB. Because that was our reference, was 2.8. That's what counts, not just down here where my finger's covering up. And here we got 100,000 hertz set up. When I readjusted the scope here, you can see it is down somewhat, but still within specs. So 500 hertz, and it's down a teeny tiny bit, right under 2.8, I believe. Also, of course, I always mention this all the time, you got to make sure that your audio generator, it's putting out the same thing at every frequency. If not, you got to go ahead and readjust it. There we go. That's the waveform. Looking good. So here we are all the way down to 20 hertz, and you can see the signal is staying steady at about what it was. 20 hertz, and here's the oscilloscope, which I already adjusted. So yeah, you can say this thing is pretty well flat from 20 to 20,000 hertz, that's for sure. So here's all my plot points. I'm not going to color this in because I think I'm going to use this again for another test, this piece of paper. Now this was the old tedious way of doing things, plotting individual points on a graph. I didn't have to do any kind of conversion or anything like that because it was basically from 20 to 20,000 hertz. It was basically pretty flat. Now the 100,000 hertz one, of course, I could have divided the one voltage by the other voltage, or I could have just went online to Peel Audio and used their conversion chart, and then I would have got the dBs down. I didn't have to use this. You don't have to use this, of course, this graph here. In fact, you don't have to use anything at all if you don't want to. Or you can make a table too and plot the dB side by side. And of course, this test would have to be done for both channels, left and right. I just did one channel. One more little thing I'm going to do. What if I wanted to do a more demanding test? As I think I mentioned earlier, I'll take it up to clipping, and then I'll go ahead and drop the voltage, basically my reading on the oscilloscope, down to about 70% of that. So I'm going to go ahead and take my peak to peak voltage at clipping, or right before clipping, and then drop the voltage, and then I can go ahead, I could plot the whole chart again like that. Well, this is right before clipping, and I think it's about 54 volts peak to peak, and I'm going to go ahead and drop that by drop it all the way down to 70% of that level. So I'm going to take this 54 volts times that by 0.7 and take it down to that level. So that comes out to 37.8. That's when I go ahead and I'm going to drop it down to. I'm going to turn down the volume control. Here you can see me dropping the voltage, going down to around 40 here, and I want to get it to around 37.8. So I changed the volts per division, and I've got about 40 volts peak to peak, and I was supposed to drop it down to, I believe it was around 37.8, somewhere around there. So that's almost 38 right there. So I would go ahead and do all my frequency tests now at that particular setting.